Okay, so just as a reminder, you should already have tried this page on your own, and so now we're going to go over it together. So this one is talking about heart disease, and we know that heart disease is recessive, so it's going to carry the lowercase allele, and we know that because the individuals are filled in. And so normal would carry the dominant allele. So we're going to start out with the individuals that we know for sure, right? The ones that have the recessive phenotype without a doubt have homozygous recessive genotype. So we can fill them in, and I'm just going to scroll down so that the whole thing is here. All right, the next thing to do would be to fill in the individuals that we know. So so let's start from the left-hand side. So in order for individuals 1 and 2 in this first generation to have children that, are homozygous recessive, the only way is for each of them to be able to give a little h. But we also know that they have a capital H because they aren't filled in, right? They have the dominant phenotype. And so we know about them. Now let's go to individual number 3. Again, individual number 3 has had children, 3 and 4, right? Have had children that are homozygous recessive, which means that 3 has to be able to give a lowercase h in order for that to happen. And so for the same reason, right, individual 4 can't give a capital H. So we know that individual 12 here has to be heterozygous, right? It's dominant because it's not filled in. It gets its capital letter from 3, but the only letter it can get from its dad is an H. So 10 is the same as heterozygous also. Okay? So here, individuals 1, 2, and 3 all have to be heterozygous. And they all have to be heterozygous because their father doesn't have a big H, right? So yet they carry the dominant phenotype. So they all have to be heterozygous. So let's go back up to individuals 5 and 6. Again, if we do the Punnett square like before of 2 heterozygous individuals, the offspring can be either homozygous dominant or heterozygous, right? Or homozygous recessive, right? So those with the dominant phenotype can be either or, and we don't know which ones these are yet. It would take them having children in order to know for sure what their genotype is. Finally, we come back to, individual 13. Sorry, it's part of the same family, so it is heterozygous. Okay, it is heterozygous, just like its other siblings that have the dominant phenotype. So hopefully this will help you to do the homework more efficiently, and I will see you all next class.